Hi everyone, welcome back to our electric vehicle YouTube channel. Today we are going to discuss about the energy efficiency improvement in an hybrid electric vehicle. How the energy efficiency is improved in an hybrid electric vehicle with the form of an bar chart. So I'm taking an y-axis as well as x-axis. So here I am considering this y-axis as energy saving, how much amount of energy saving. On the x-axis I am taking the magnitudes at different level. So when you use an hybrid electric vehicle, so this electric vehicle is a combination of a battery plus motor, and this is a combination of an engine connected to the motor. So this is called the combination of a group of powertrain, which is called hybrid electric drivetrain. Now when you see here, so this IC engine we cannot do anything. Why? Because this IC engine has lot of problems. So the efficiency of this IC engine can be improved by implementing an concept or implementing a feature which is called as a start stop feature. So here I am implementing this start stop feature in an IC engine. So this is nothing but 6%. So this is due to start and stop feature. Sir, what is this start and stop feature? Actually, this IC engine, we want to run the engine in ideal mode, or we have to run the engine in traffic in standby mode. So we cannot turn off the engine multiple times. It should run continuously. So due to this standby, it creates an loss of 6%. Okay, but we are going to implement a feature which is called as so this generally in vehicles we call it as a engine kill switch. Kill switch. So you can see now a red color engine kill switch will be there in IC engine. By using this engine switch, we can make the engine on and off multiple times. So key will be, engine will be on, but the key will be on, but you can make the engine on and off by using a single switch, where this switch is called as a engine kill switch. So by using this latest technology of engine on and off switch, we can create an energy saving of 6%. So by in traffic or in suddenly we need to stop the vehicle number of times, we can use this feature, and we are going to improve the efficiency of 6% by implementing a feature called as a start stop feature in internal combustion engines. Okay, so that is about the start stop features of an hybrid electric vehicle. That's how the improvement you have been done. And already we told in an hybrid electric vehicle, so in an hybrid electric vehicle, so this motor, it was there. So for example, our electric vehicle is climbing a ghat road. Let us consider the ghat road as Tirupati, and the higher is Tirumala. So when you are traveling in positive slope, this will try to act like an motor. But when you come down from the ghat road from with a negative slope from Tirumala to Tirupati, automatically you are going to have a negative slope. So in this negative slope, this motor will try to act like an generator, and the wheels are freely rotating in negative slope, and this motor acts like a generator, and this will charge the battery, where this is called as a regenerative charging of battery. So by this method also we can improve the efficiency. So I'm drawing the resultant improvement of efficiency. So here already we have been got 6% increment due to start and stop of IC engine, and we are going to have the 6% improvement of energy saving due to regenerative braking, or due to regenerative braking mode of operation. We are saving an energy save of 6%, where 12% ultimately we have been increased with the help of start stop feature, and 6% due to regenerative braking feature. So due to these two features, we have been saved around 12% of energy in an hybrid electric vehicle. So next feature what we can have is, So we are going to have one more improvement in feature. So this base is 6% due to start and stop feature. Next we are going to have remaining 6%, and here we are going to have the one more 18%. So, okay, so overall if you take this is 12 plus 18, approximately overall we are going to have 30% of energy saving. Sir, why this 18% of energy saving has been came into the picture? So now, why this 18% of energy saved means, so we are going to operate our hybrid electric vehicle in combination with IC engine and in combination with an electric motor. So here IC engine is also running with the highest efficiency, motor is also running with highest efficiency. When you combine the performance of an IC engine with the performance of an motor, around 18% of energy we are going to save. So that is why the energy is saved with the combination of operating IC engine and a motor when you are traveling in a grade area which is having an positive slope, or an when you travel on a ghat road. So in this ghat road, which is a critical type of driving with the positive grade angle or gradability of 10 degrees also, we are having better saving in energy when you combine the power of an IC engine with the power of an electric motor. So better energy is saved when we use an hybrid electric vehicle. So ultimate theme is how the energy efficiency is improved when you combine the electric vehicle with an IC engine. So electric vehicle in combination with IC engine is called as a hybrid electric vehicles. So 6% of efficiency we are increasing with the help of a start stop feature, and one more 6% the energy is improved with the help of a regenerative type of generating the power, which is called regenerative. So don't think that regenerative will be occurring only in the negative slope. So when you remove the acceleration, okay, you are driving the vehicle and remove the acceleration, automatically the vehicle will be freely rotating on the flat road. It will try to generate the power, that is called as regenerative braking. Regarding this demo of this regenerative braking, we had demonstrated with multiple electric vehicles. I will leave in the card, you can see there. And so like this 6% due to start and stop feature, 6% due to regenerative power which is generated from the hybrid electric vehicle, and 18% of energy is saved by operating IC engine as well as internal combustion engine combination. Overall 18% of energy you are going to save. So 12 plus 18, 30% of energy saving. You can see here approximately 30% of energy we have been saved when we use an hybrid electric vehicle. This is all about how the energy efficiency is improved in the case of an hybrid electric vehicle. So this is all about energy efficiency improvement of an hybrid electric vehicle. So if you want to see the figure, this is the figure of a hybrid electric vehicle. So you have an fuel tank, already we explained in series hybrid electric vehicle. You have a fuel tank, you have an engine, you have a generator connected to the rectifier which converts the AC to DC with the help of an converter, and this DC can be connected to the with the help of a DC converter will be connected to the motor converter, which supplies a suitable voltage and current to the traction motor, and automatically this total traction motor will undergo an differential or torque splitter. The resultant torque is available at vehicle 1 and vehicle 2. So here this is where we are going to call this as powertrain 1. So this is called powertrain 1, and this is called as powertrain 2. So combination of powertrain 1 and powertrain 2 is called as a hybrid electric vehicle. So this is all about a energy efficiency improvement of an hybrid electric vehicle. So hope if the video is useful, please like and please share with your friends and subscribe to our channel to get more updates on this electric vehicle. So if you do all these things, where our channel grows, where we can do good useful videos on electric vehicle freely to the students, where this will help us to do good videos for you. So hope, thank you for watching. Yours obediently Ram. Thank you.